Alright, so we'll get into section 1.4 here, which is some more terminology. You're probably familiar with a lot of it, so we won't go that slow. So we have a segment is a part of a line. So if we imagine, remember, a line goes forever in both ways. If we cut part of that line, we get what's called a segment. And it's contained by the endpoints, which, as they sound like, are the points on the end. Array has one endpoint and points in one direction. So it extends, we talk about like sun rays, right? So they start at the sun and they go in one direction out from the sun. And then opposite rays are two collinear rays that have the same endpoints. So if we were to just try to sketch something out, a segment would be from A to B. It has a finite length. A ray would be from A to B, but it would extend forever, so it would go all the way out in that direction forever. And then opposite rays would, let's say we start at point C, and we go, one goes this way and one goes that way. They have the same endpoints. So the collinear, we haven't talked about it explicitly yet, but means that they are the same line. So if we want to name some rays, name the line, we have AB. We could name it lots of different ways, as we talked about before, but AB captures that line fine. Segment is BC. Now you can notice a difference. To show that it's a segment, we don't put the arrows on top of it, right? So we just have a line on top that stands for the segment, the physical segment. We'll talk about in a moment if we drop that segment from the top, what that means. But that means that physical segment from B to C, that piece right there with our notation. If I have a ray, that's from D to A. So now this is important. If I look at line segment DA, it means it starts at D and I go towards A. That is not the same as starting at A and going towards D. So this naming convention is important in terms of order. If we look at segment BC, right, going from B to C or C to B doesn't make a difference in that segment, but array will make a difference there. And if we talk about, so we have a start and where it goes towards, just like that. And then if we have BA, there's B from A and then B to C, again, where B is at center point and they're going in opposite directions. Alright, we have some more terminology. So we have parallel lines. You've heard that probably before, I'm sure you have in a previous math class. They're coplanar lines that do not intersect. So often students forget the coplanar part. And our difference is going to be with skew lines. So parallel lines are in the same plane and they don't intersect. Skew lines are lines that don't intersect, but they're not coplanar. We'll see in a second if we get into 3 dimensions how that really looks. So if we want to name a line parallel to MR, well, that's going to be LQ, that's going to be OT, and that's going to, if we look at it, there's MR, and then those are the lines that are parallel to it. Now, if we think about the plane that goes to them, it's easy to see over here what the plane is, but if I have MR and I have OT, there's a plane that runs through them like that, through the diagonal of the box that would capture them as we look at it. So if we want to name line segments that intersect it, MR, line MR, well, we have MN, we have RS, and then we also, just because the line's not drawn there, we could go from this corner to that corner and get line OM. That would intersect that line there. So you can see there's lots of lines that are going to work as we go through it. And if we name them as segments, we again want to not put the arrows on the top, just put the line on the top. Alright, so lots of lines that exist. I should have no segments on top of that. There we go. And then let's look at the last part. I want something, this is the hardest one to realize, something that's skewed to MR. So there's line MR. Skew means that it doesn't intersect it and it's not coplanar. So if we look at it, there's QT. Well, it's not going to intersect it. I can see if I was to continue MR up and down forever, it's not going to cross it, right? But we wouldn't call those parallel. They're not in the same plane. So here's the plane that contains MR, and then QT comes out of that plane. So those are skew lines. If I have planes, if I go from 2 dimensions to 3 dimensions, just like we have parallel lines, we can have parallel planes as we go do this. And then we can have different examples in the classroom and looking at parallel planes. The ceiling and the floor are often easy. And then a plane parallel to a line in the classroom, if we look at a line formed on the floor, and then something on the ceiling, the plane of the ceiling, those are going to be parallel. So if I want to name a plane that is parallel to plane LMN, well, here's LMN, it's that top piece, and a plane parallel to it, I could take the bottom piece, that would work. And I'd pick 3 points and name the plane. And then a line parallel to plane LMN, well, LMN is again on the top. If I take QR, that would work. QT, that's going to work. There's going to be more as well.